Let's use our complete the square skills to solve some quadratic equations. Here's an example. We want to solve this quadratic equation by a method of completing the square. Notice that we don't have 0 on the right, but that's fine. Let's look at what we would need to complete the square. Is 9 what we need in this case? Well, it is. So we can just write the left-hand side of the equation as a perfect square of a binomial. And now we're going to use our taking square roots method for solving. So that means that if we take the square root of the left side, it could be the positive root of the right side or the negative square root of the right side. And on the left side, that just simplifies to x plus 3 because the square root and the square cancel each other out. And on the right side, the square root of negative 1 is 1. So we have x plus 3 equals the plus or minus 1. Now let's go to a new screen so that we can continue working with it. I'm just using the same one we had before. But what does that plus or minus symbol mean? It means that in one case we could have plus 1 on the right, or in the other case we could have negative 1 on the right. So we write two equations, and then we'll solve each equation one at a time. To solve the first equation, we subtract 3 and we get x equals negative 2. To solve the equation on the right, we're also going to subtract 3, but we get negative 4. We think these are our two solutions. What should we do? Yes, we should check it. So we're going to check both of our solutions in the original equation. So when x is negative 2, we're going to do negative 2 quantity squared plus 6 times negative 2 plus 9. That's the left-hand side of the original equation. And when we simplify it, we get 1, which is what we wanted it to be on the right side. So that worked. Let's try the other one. When x equals negative 4 and we substitute negative 4 for x into the original equation, we also get 1. Yay! So they're both right. So we know that that solution worked. Let's look at another example. Here's another quadratic equation. This time it's 0 on the right. It doesn't matter what's on the right. What we care about is what's on the left. Is negative 96 the right constant that will complete our square? No, of course we know it isn't. So we want to move that to the other side. So we're going to add 96 to both sides of the equation. And when we do that, we're going to leave some room so we can complete the square on the left. What is it that completes the square for this binomial? Well, using our pattern, we know that we have to take half of the coefficient of the x term and square it. So we need to add 4 to complete the square. So let's do that. If we add 4 to one side of the equation, we have to add 4 to the other side of the equation. And then on the left, we have our perfect square trinomial, and we have 100 on the right. That's fine. So we're going to write the square of a binomial on the left. That was the whole point of completing the square. And now we're going to take the square root of the left side, and we know that we could get the plus or minus square root on the right. Now I'm just going to write this over again, the same thing we just got here on a new screen so we can keep working with it. So this is where we left off. The left side simplifies to just x minus 2. The right side, we don't want to lose track of plus or minus, but we can take the square root of 100, that's 10. Now we have two equations, one when 10 is positive and one when 10 is negative. So let's write out our two equations so we can get our two solutions. Solving the left-hand side gives us x equals 12. Solving the right-hand side equation gives us x equals negative 8. Now we're going to check them both in the original equation because we want to make sure we didn't make a mistake. They have to both work or we have to go back. So when x is 12 and we substitute it into the very original equation, what we're looking for is 0, and we get 0. When we check negative 8 into the original equation by substituting it in for x, we're looking for 0 again, and we get it. So we know both of these answers work, both of them are solutions, so that's the solution to our original quadratic equation. Okay, I think you're ready to try some on your own.